Alright, I'm doing my reassessments on 17.1 and 17.2. The first question I did was 17.x.1. A proton initially travels at a speed of 3,000 meters per second. After it passes through a region in which there is an electric field, the proton speed is 5,000 meters per second. What is the initial kinetic energy of the proton? What is the final kinetic energy of the proton? What is the change in kinetic energy of the proton? Okay, so first, this is 17.x.1 for 17.1, and here is where my proton began at 3,000 meters per second, and here's where it ended at 5,000 meters per second. So I need to figure out the kinetic energy of the beginning of the initial point. And here's the equation: is 1/2 m p means proton, the mass of the proton, velocity of the initial velocity, which is 3,000 squared. And then I plugged in the numbers for the mass and the velocity, and I ended up getting that number, joules. And then let's see, okay, and then I did the kinetic energy of the final, and so I pretty much did the same thing but plugged in 5,000 instead of 3 and got that, joules. And so final minus initial, so final minus initial equals this, and that is 17.1, 17.2. Proton moves through from location A to location B in a region of uniform electric field, as shown in figure 17.5a. The magnitude of the electric field inside the capacitor in figure 17.5 is 3,500 newtons per coulomb, and the distance between the location A and location B is 3 millimeters, comma. What is the change in electric potential energy of the system, parentheses, proton plus plates in parentheses, during this process, question mark? B. What is the change in kinetic energy of the proton during this process, question mark? C. If the proton is initially at rest, comma, what is its speed when it reaches location B, question mark? So, alright, so basically 17.2, this is 17.3, x.3. First I was solving for change in potential energy, which equals negative E. E is the charge, and that's what the charge is of the proton, times the electric field, which, I'm sorry, it's not x, it's y, but up and down, and then the change in y. And you plug and chug, basically, and you get, this was in millimeters, so I had to change it to meters, the electric field, and I got negative 1.68 times 10 to the negative 18 joules. Now the conservation of energy is potential equals kinetic. So change in kinetic energy plus change in potential equals 0. Change in kinetic equals negative change in potential. I'm sorry, I meant earlier change in kinetic equals negative change in potential. That's what I meant. So change in kinetic equals 1.68 times 10 to the negative 18. All you had to do was, change the sign. It's pretty great. Lastly, kinetic energy final minus 0 equals 1/2. I'm solving for the velocity at the ending point at B. Kinetic energy final minus 0 equals 1/2 mv squared minus 0. Vf equals 2ke over m square root, and you just come from there to there. You plug and chug. We got this from right here. And here's your answer. Thank you.